Okay. Okay. So, hello everyone, and welcome back to this. Wait a second. To this, live stream where we take a look at Odin and build an example project with it that is of reasonable size. And over the last few streams, we got to the point where we can serve some static assets using and have multiple connections per thread. At the moment, we only use one thread. And I was thinking about what could be the next thing we can do. And there are several things we can look at. But I think what's the most interesting to me right now is looking at our hashing mechanisms. So at the moment, we have essentially two places, or more or less three, but really two places where we need a hashing mechanism, right? We can think about this. Yeah, I have an idea for the second one, but I will write that down. So. So 1 second, I had an idea. So let's open Excalidraw. Let's change the scene. And I already did some, but very limited research. So essentially what we have, or what the two places are, is the following. So we have the first place, obviously, is the HTTP header map. HTTP, let's make it a little bit bigger. HTTP header map. And I guess in the spec it's called header message header, or let's see, RC, HTTP RC, Google. And they call it entity header request header fields. So they call this header fields, request headers. So I just called it HTTP header map. And what it does is basically map a field name to field value. And at the moment, we have a very, very simple implementation where this header map is just a linked list. So every time we encounter a new header, we say we allocate some memory with our arena, new HTTP header. I don't know the type right now. And then we allocate that with our arena. And all of these headers obviously have the same lifetime, and they get cleaned up when the message goes out of, when the message's lifetime ends. That is if we have a complete message and send the response. So this obviously is not the best way to do it. So we have what we end up having is something like this in memory, where we have a header, a header, a header, and a header. Let's say we have 5 headers. Okay, let's say this is, for example, accept, and then star. I don't know if that's the right thing. And this is, for example, connection. This is the user agent, and so on. And then we have some field. No, this is not a header. This is a header entry. And the header entry has a header. We can look at this. So in http.odin, we have an header entry which has a next and the name and the value. Okay. So everything's stored in this entry. And obviously we have here a pointer that points to the next one. And as of now, we implemented like this, that they're contiguous. Like the first one, oh no, it's not even this. It's like this, right? It goes backwards. How we do it is we append to the head. So in the first iteration, this is the head, then this is the head, and this becomes the next, then this is the head, this becomes the next, this becomes the next, and so on. So it's like this, right? So it's backwards. which might not be good. But it's contiguous in memory. And what I thought would be kind of a good thing to compare to is just having it as an array. Obviously, the downside is this will not be dynamic. This will not be dynamic. So we need something like a max HTTP headers. If that sounds reasonable. Odin mentioned, true. The hipsters. Okay, so what we could do is have just an array. Are we hipsters? I don't know. Maybe some would think so. So what I was thinking about was comparing this approach with the linked list, which is obviously not very great to implement this kind of map, because every time we want to find something in the map, we have to go through all the links here. They are contiguous, so I don't know what the performance penalty will be, but yeah, we have to see. So compare this linked list approach to something that has a fixed array with max HTTP headers, and then just fill the array like so. And every time we want to get from the map, we just iterate through this array from 0 to length to max HTTP headers -1 and see if we find it. Which worst case have to scan through all of the headers. Okay. And the third thing I want to compare this to is a real hash map that uses a hash. So we have again some backing array, but we compute a hash based on the input. So this would be the field name. And then use the hash to index this array. So this would be mod this, and then we use the hash to index the array for both the insert and the get operation. And obviously, this here may not be trivial, but I looked at some hash functions and I found this XX hash, which was originally designed for hashing big files. So I don't know how it performs on relatively small inputs, but I believe XX hash has some code paths for small and long inputs. So there might be different code paths that are taken, but I'm not sure. And Odin also has an XX hash implementation, which is kind of nice. And I thought it was just linking to the C implementation of this, which is here, XX hash. We might try something like city hash as well. Here's city 32. Yeah. Or city, where was it? City 120, no, not city 128. That won't really have any advantage, I guess. So what's the server going to be for? So initially, I was just trying to implement something with the language to get a feeling for the language. So I've never used it before. In the first stream, we took a look at the overview page, so odinlang.org, and looked at the overview and read through it, not completely, but we got a good grasp for what it does. And then I started to implement something that is real and does some work to see what the language can do. And so far it's been quite nice. It's been a good experience. And so at the moment we can look at this. If we build this, Odin build and start it. No. So we have assets here, about and index. Oh, I've been enjoying Odin a lot, building my DB in it. Okay, that sounds nice. Building a database. What's your database then? What's the database you built? Is it a kind of relational database like Postgres or so, or is it some NoSQL thing? But that sounds nice. I don't have a lot of experience with the language, to be honest. So yeah, you can Google SwitchDB. Okay. And okay, 1 second. Let's actually look that up. So it's SwitchDB. Oh, yeah, that's you. Server mode with natural language processing. Sounds nice. A no JSON, no SQL database. Okay. Cool. Let's see, source. Nice. Nice, so you have some experience with it. That's kind of cool. Is that for a company or is that your thing here? And why? Yeah, okay, nice. So some other things in Odin as well, some Go. Cool. Okay. Yeah, our HTTP server is more like something like playing example, and it can serve some assets, some index.html, and so if we go here, index.html, and we'll see how far we can go with this, but it won't obviously be a spec compliant thing. I will use it to explore some things. Okay, so back to what we wanted to do. What experience do you have? With the language, I don't have a lot of experience, and with HTTP servers, also not very much. I once started building one in C, never really finished it, and it also was pretty crappy. And thank you for the follow. That's nice. Let's go back. Okay. I'm in general use of programming languages. So I started programming. Oh, let's see. So I'm 23 years old right now, and I started when I was 14 or so. And so I started in school. We did a lot of Java, which is yeah, you know. I did some back in the days. I did some Minecraft server things, like almost everyone my age did. It's kind of, yeah, everyone sort of started with modding games. And recently what does recently mean? So I did some Python for my studies, so I study data science, and obviously there we do a lot of Python for the data science stuff. And recently I did a lot of C and C++ and lower level stuff, and now I try Odin. And yeah, so far I really like the features. So I'm not I'm 30, been programming 3 years now. Wish my schools taught programming. Yeah, you know, that's right. If you have a school that teaches, but I don't know. Our schools, they teach Java. So I'm located in Germany, and I don't know if they still do it, but they teach this. They teach Java and object-oriented programming. Which I don't really feel like is the right place to start for programming. I think you should start. You should get a feeling for how the computer works, and I think Java is not a really good point to start there. I mean, of course, you get these programming idioms and start with C. Probably that's the best place to start as well. Yeah, I think so as well, because C really lets you interact with the system on a level where you get a feeling for how the computer works. For example, if you always just stay in this garbage collected object oriented world, you don't really get to know how you can make things fast, and what the trade-offs are if you use these languages, like garbage collection and stuff like that. And I think you should be aware of these things to be a good programmer. Yes. Okay. So what I wanted to do is something else. So I wanted to compare these 3 things. Where is it? This linked list thing, then the array-based approach, and the array-based approach with a hash. And first and foremost, we need some data to benchmark all of the 3 approaches. And I'm not sure how we should go about this. Yeah. I'm not sure. So I looked at the most common HTTP headers. How could we do this? So what I want is some test loop. Yeah. So I want an array that represents a set of headers. So let's say we have connection, close, oh god, help. We have connection close. Oh, why does it not work? Okay, here. Connection or accept. Accept star. We have the user agent. I don't know. Curl. We have, I don't even know what with host. And so yeah, maybe a couple more. Probably, I don't know how many headers there are typically in a they're typically sent. We could look at a header that is sent by Safari to our HTTP server. Like if we look at HTTP and when we read, let's just print format.println bytes read, no, parser.buffer, parser.offset to parser.offset bytes plus bytes read. Let's build this. Oh, Odin build U32. Let's see what Safari sends, for example. Localhost 8080 index.html. Oh yeah. This always gets me. Print FLN. And let's see. So we got this. Accept language, accept user agent, host connection. So these things are probably every time in there. So user agent and accept and some things like that. Yeah, now what I wanted to do is have a set of these and have multiple of these. With some randomness in them. And then I just want to feed them through. So I want to insert all entries, and then I want to get all entries. And getting them should also be something random. Yeah. So an HTTP, no, it's hash.odin. Maybe we also want to generate maybe we also want a script to generate the things. Okay, let's say we have a script that says, okay, hash test generate. Probably this should not live in here. main, but okay. Let's just make it happen. So core format. And I want some headers that could be, I want some header list that we can choose from. So header list or header list string. And then we get something like this. Or maybe this is, or this should be already in. Yeah, maybe we put this already in the hash Odin. So header, test header list. And this has something like connection and close and connection, keep alive, or was it keep alive? Authorization. I mean, the values don't really matter, right? It could also be random, I don't know. And let's also have something like user agent. So this would be always include headers. So this would be user agent, this, let's say accept also. Test agent, test accept, connection. Accept encoding. And random header, random headers. So this would be accept encoding for, oh yeah, host also. Yeah, host should be included as well. Referrer. Test referrer. Also, we could ask the chatbot to do this for us. This would be probably a good thing for the chatbot. Accept language and accept encoding. Accept language. Yeah. Can you generate? Is this? Can you generate a list of headers? No. I want to generate test input for benchmarking different implementations of a HTTP header map, and using common headers and headers that are less common, where we always include the common headers and randomly include the non-random ones. I am doing this in Odin and use an array of 2 strings to represent the field name and field value, like so. String what is it? Shift 1, 2, 3, 4. Connection test connection. Accept test accept. Can you fill in some common headers and less common ones? Okay, maybe we can just copy this. Correlation ID? Okay. And let's call this common headers and less common headers. Okay. Oh yeah, content length, also very nice. Content type. Yeah, that seems good. How many headers are typically in an HTTP request? We should also test varying sizes of headers, like how would we do this? So this is type header map. Yeah, no, this is not type header map. This is like this. String. Okay, so let's just store them. So we need multiple header maps. So let's say HEP header map LL for linked list. Then HEP header map array. HEP header map hash. Okay. Then we have LL get and LL insert or spilled some water. Great. 1 second. I'm still wondering if this is a good idea to do it this way. Yeah. Is it a good idea to do it this way? I don't know. Let's just try. I mean, this might create some behavior which is unexpected, because we always like use the same kind of things. Maybe we just dump this to a file. Yeah, let's make an example file. Or should we? I mean, it would be kind of better to have it in a file, right? But I don't know. And then just read the file to perform to check whether. Okay. Also, if we always do it the same, I don't know. Should we dump it to a file and then load it to benchmark it? Or not? Maybe let's just try to do this. So array insert array get and hash insert and hash get. Okay. How do we generate these samples? So let's say we have so insert would be, the insert procedure should take the HTTP header map LL, so map, and then we insert with the name or key and value, right? So this would be the interface, and this returns the result U8, probably also bool found or not found, or error. It's called error. And this takes the map, HTTP header map LL, and the key. So let's have a header count or header message count. And we also want some distribution of various header counts to also test that. So let's say we just have, I don't know, 128 messages or 64 messages, and for each message we want, should we have a header type? Or a header list? I don't know. So let's say we have an HTTP header entry. This is a struct, and this has a name, a key, U8, and the value, U8, and entry LL. This also has a next, which is a pointer to a HTTP header entry LL. And this has a head, which is a pointer to HTTP header entry LL. Let's have an HTTP header entry, which has a key and a value, because we probably need that for each and every one. to do explore in direction of values. Maybe also do this format thing. I think it was like this. S? No, was it like this? I don't know. It was http.odin format. Yeah, it was S without the percent sign. Okay. So then we have the inner or entry, which is an HTTP header entry. Okay. Is it like this? Yeah. Okay. And when we insert into this, we just say yeah, let's just use the temp allocator for this. So we say new HTTP header entry LL with the context.temp allocator. This is the new head or field. Let's call it field. Field.key is equal to key. Field.value is equal to value. And map dot, let's call temp map.head, map.head, or we could also say field.next is equal to map.head, and map.head is equal to a field. This is the insert method, and this will be the get procedure, where we want to iterate through all of these things. So for, let's call it entry map.head or field. For field is not equal to nil. Error is equal to true. And then we have to say memory compare as a method. And it takes two values, A and B, if the length of A is not equal to the length of B. This just returns a bool. Then result is equal to false. We return. Otherwise, we go through for idx in 0 dot dot length of A. If A at idx is not equal to B at idx, result is equal to false and return, and result is equal to true and return. I think result is equal to false by default, and then we can just say return. And then we have to compare these. So if memory compare the key, the field.key with a key, then we say result is equal to field dot value and return. And if that's not the case, we set the field equal to field.next. So this would be the linked list thing. So HTTP header map array has just the array, right? So this would be HTTP header entry. Array init. We need a size. And the size U32. Then we say make HTTP header entry with the size and the context.temp allocator. This is equal to map.array. Then we insert into the map. Hello. Not silver. And we insert with the key and the value. What is Odin? Odin is a programming language. And map. So if probably also this can return an error now. Let's just assume that this cannot return an error for now, but to do this should return an error if we can't insert. So map.array and map.array no. So this would be the capacity, and this needs a length as well. And then map.length is equal to 0. Probably the do program in other languages that look like C. I programmed some time ago some things in C and C++. Other languages that look like C, I don't know which languages would fall into that category. That look like C. I know, I did some Rust, but Rust doesn't really look like C. Go looks like C. No, like if you're a programmer with JSS stuff. Like you've ever programmed with JSS stuff. JS. I did some JavaScript, but I'm not proficient in it. And yeah, I didn't really do any JavaScript besides some very basic stuff. It's also been quite some time. So map.array at map.length is equal to key value, right? I have a question. Like, is that like a VPS you are creating? A VPS. What is a VPS? VPS server. Virtual private server. I'm trying to get a feeling for the language, and created this example project, toy project of an HTTP server. I mean, we can look at it. So I created this very basic HTTP server that is basically capable of serving some static assets found in this folder. So if we cat assets index.html, it looks like this. At startup, we load this file, we parse HTTP messages, and if this thing runs and we open it up in our browser, we can get something out of here, right? About is not there. See, you're on Linux? No, I'm not on Linux right now. I'm on macOS. But I use this machine for streaming because it's quite convenient with the hardware, because it has hardware accelerated encoding, and my other machines don't have it. But we will port this to Linux at some point. Okay, that would be that, and map.length plus equals 1. Looks nice. Yeah, I just saw the bug. I just saw a bug where if we put something that we don't have there, it somehow hangs, which should not happen. So if we curl v localhost not found, close, but it doesn't close. Probably we should also send a content length 0, but I'm not sure. But this looks right. So what if, let's just fix that. I don't know if we have to send a content length 0, to be honest. So write response. No, it's handle get handle request. Okay, so if we found the asset, connection literal, close literal, content length. Why did we call this content length entry? So this is connection entry, and connection entry. And we also want a connection entry content length entry. This is equal to the content length literal and the value u32 to string. We had that, right? Length of the content, U32, length of content. Oh, yeah, that's just, I mean, we could have a 0 literal here, so, because this is probably a code path we likely hit multiple times, so let's make it just a 0 literal. So literals, 0 literal, like that. And then we set content length entry dot next equal to response dot header map dot head. I mean, we could do something like this where we set the next to connection entry. We really need an insert. We really need an insert routine here, but whatever. And set the head to content length entry. Let's see. So at some point, where's the format.print line? Print FLN here. Let's build this. Uh-oh. It also builds hash.odin. Let's just comment all of this out. Probably it builds it because I imported it here. Hash.hashme. Okay, HTTP. Let's see. Yes, so if we insert a content length as well, it does something. So let's see, about works. Let's insert something and not found. Okay, great. That works. And also is asynchronous with the KQ and stuff. Okay, so let's continue. Map.head. Let's see. Map.length plus equals 1. Array get. This is the map, HTTP header map array with a key, and it returns results and error bool. So we go through for entry in, or for field in map.array. No, we should do for idx in in 0 map length. Let's just say this is the field, which is of type pointer HTTP header entry. Field is equal to map.array at idx. I don't know. And then if memory compare field.key and key result is equal to value, field.value, and return. If we are here, we just say error is equal to true and return. Very basic. Now the hash map will be a lot more work to do. HTTP header map hash key weight value u8, and let's copy this and delete the value, and also results u8 bool error bool. Okay. So we have to generate some example data. Let's just say an HTTP message has a map. Oh, not a map. It has HTTP header entry, fields, okay. So let's make a method init messages. Let's call init messages. Nope. HTTP header, HTTP message, messages. Let's just make HTTP message count with context.temp allocator. Nah. I don't know if we should use the temp allocator for this, but okay. So this is messages. And we initial, probably this is not large enough. I don't know. We init the messages. We go for message in messages. We first have to pick a size, like we need some distribution. So this is Maybe we shouldn't have a message count. So what I want is something where we have that can generate messages where there's only one header, where there's two headers, where there's three headers, and it's not always the same. Okay, I have to pee, and then I'm coming back, and then we're gonna do this. Okay. Init the messages. So first and foremost, we have to we need some distribution. So let's just say, okay, whatever, this is rand. How do you random in Odin? Random choice. Okay, we could do that. So rand, so this would be field count in here, which is a random. I think it was rand max, right? Rand max or int max. Yeah, int max. Int max. So no, it's rand dot int max. Import core rand. Is it core rand? It's core math oh man, math rand. And so this is the field count, which is the maximum is the length of common headers. So can this return? This is not include. 0 n. So this was not inclusive, right? Yeah, this is exclusive. So this would be the length of common headers plus, no, this is wrong. This is the length of less common headers. Less common headers. And then the length of common headers plus this. Then we have to make an HTTP header entry with field count and the context.temp allocator. This is the fields. This is message.fields. And then for field in message.fields, we first want to fill in those here. So field.key is equal to, no, first we have to go for idx in 0 dot dot length of common headers. Let's insert them first. Field, and the field is equal to message.fields at idx, and then field.key is equal to common headers at idx at 0, and the value is at 1. And then we go through message dot 0 dot dot field count minus, no, let's make it less, random field count, and this is the length of common headers, and plus the random field count. And this is up to random field count. So the field is equal to message.fields at field count, now length of common headers plus, this is idx field.key. Now we need a random.choice, right? Random.choice, rand.choice. Rand.choice. Random choice less common headers. Should they, I mean, it should not be chosen twice, right? Whatever. For now, to make it such that two headers are not chosen twice. Two times. So the field.key is equal to, so what is this again? What is random.choice? Return the element. So this is a how do we call this? Choice header 0 field.value header 1. So we fill all of them. We fill all of them in. Maybe pre-initialize the distribution. And not draw from the RNG. Okay, so we initialize the messages, and then we do something like for, yeah, here's the test harness that processes through all messages. So for message and messages, insert LL insert and for also we have to reset this. So we cannot use the temp allocator. So let's say this LL thing also has an arena, which is a runtime.allocator. LL init. Or maybe it's not stored in here. Runtime.allocator, whatever. Arena. And then put in the arena here. Arena, runtime.allocator. Okay. Let's say we have an arena. This is an arena. We say arena init, arena. Now, what is a max size? So it's the size of an HTTP header entry. HTTP header entry. Size of this. And then it's the arena alloc is equal to mem.arena allocator arena. It's the size of this, and this is the length of common headers plus the length of last common headers times this. So we do this, we do a for field in message.fields, ll insert, and free all arena alloc. ll insert the field. So this is, let's say we have a ll map HTTP header map ll insert all fields, and then for field in message.fields. So this is field dot key field dot value, ll get field dot key, value is this. Maybe we have to do something with the value in order to not get it optimized away. So this is ll map. This is also ll map. Yeah. So does this compile hash? Nope. Let's see. So this is in line 115. What does it tell me? Expected statement got an equal. Okay, probably the error is something further up the line. Let's start at the top. Expected package. Oh, there is a package. Oh, hash test generate. So let's just delete those two. I expected an identifier in 74. What? Am I doing something wrong? Well, obviously I do, but expected an identifier. Oh, we cannot use map. Header map. That's bad. Header map. Map. That's a little unfortunate. So there's still something. Still, it's here. Value. I'll get error if error not assert error not equal nil. Assert error not error. Okay, now we don't have a runtime. Import base runtime. Parameter arena of type allocator is missing. Okay, ll insert arena alloc. Can assign value. Okay. Let's say key is equal to transmute field.key and value is equal to this. And key is equal transmute field.key. Okay, still somewhere in 153. To transmute so we did it at the wrong spot. Field header entry LL has no field. LL gets. Yeah, it's field.entry. Expected 2 arguments, got 3. Oh, LL get does not take the arena alloc. Okay, we don't have mem. Import core mem. Field of type has no field key. 78. Field.entry.key. Field.entry.value. Undeclared name arena. Mem.arena. Did you mean reference? Yes. 88. Entry.value. Undeclared name arena in 171. Yeah, because it's arena. And it's mem.arena in it. Can I determine polymorphic type from parameter? Last common headers. Last common. No, it's rand.choice. Header 0. So this is transmute U8. Can convert untyped value. Arena init. How you do it again? Arena init. Okay, we need some backing buffer. Backing buffer. Make slice U8 $, this backing buffer with the context dot runtime temp locator. Okay. Hash segfaults. Great. Let's do LLDB hash file hash run. This is in insert p field. Field is null. Is the backing buffer full? So let's break at hash.odin line 174, 175. Let's run this. It inserts. and then it frees all. I wonder why at some point it doesn't work. Format.println. One, two, so after 6, this is always, no, it's not always the same. Random field count. Random field count is 0. Doesn't really depend on the random field count. One message can only have so many of these. HTTP header entry LL, right? Is that the problem? Yeah. Okay, so now it works. That's good. Maybe we could do both. Forward scan and backward scan. Reverse. Okay, and we would need something like this for every one, right? So if I LDB hash, let's say break at 169, break at hash.odin 169, run, print messages 0. Oh, okay, so it's data 0. Messages.fields. Messages.data 0.fields.data 0. Okay. 1, 2, 3, 4. Let's print this like p-array. Let's print the 1. Oh. Print messages.data 1. This is also 14. Also 14. 29, 27. How many are these? So 21. Hello, penguin operator. Okay, so we have something that tests. Yeah, we don't really have a test harness right now. So what we would now have to do is also this doesn't really simulate the insert in the sense that these memory locations are always the same, but I mean it's the same for all, so I guess that's fine. Let's see. So maybe at this point we should implement some tester. Let's make it a little bigger, right? Still quite fast. 2048. I mean, how many messages should we process? 655365. Now we're talking. Okay. So let's do these many. Oh, 6, 5. What is 2 to the power 2 to the 16? 65536. 65536. Like this. So this is quite slow, I guess. So is it aggressive? Yeah, we'd have to take a look at what exactly is optimized away here. But maybe let's first implement a test harness. So let's have something like a repetition tester. That has something like a min time, U64, max time, maybe a hit count. It also has a accumulated time. Maybe it also has a name. And maybe we should pull this out into a different file. Let's say repetition tester.odin. Package HTTP. Open blocks, closed blocks. This can also be U32. Does it need something else? And we want something like a begin time, an end time. We also want something like a byte count. Tester, repetition, tester. Tester, repetition, tester. Start time. Yes, the character, that means pointer, that's right. And count bytes, proc tester, or count units. I mean, units is more generic. Kit count, unit count. And U32 unit, no, U64 unit. Say tester dot unit count plus equals unit count. So begin time, last start time. Tester dot last start time. Now we would need something like a clock get time here. OS get time. Proc returns a U64. Gets nothing, and I don't know how you do that in Odin, so there should be, where is it? A clock get time. Clock get time. So something like clock time.clock. Time.now. Contextless what? Okay, let's just use POSIX. So import, is it core POSIX? POSIX. It's core sys POSIX. Core sys POSIX, and it's POSIX dot, maybe using POSIX clock get time. You can also do this here, results and clock get time, clock get time. This gets a clock ID. So this will be dot monotonic. And a time spec. Let's just call it time. Okay, so that is a libc time spec. Okay, now we also have to import libc. Where's my browser? Libc core-c libc import core-c libc. So clock get time. This is a libc time spec. Then time. This returns something. Possibly an error. Clock get time. A result. Okay. Let's just assert that this is equal to dot okay. And then we say result plus equals. Let's say OS frequency is equal to, I guess that's 10. 1, 2, 3, 1, 2, 3. I don't remember. Is it 1? I think it's 1 nanosecond. 1, 2, 3, 1, 2, 3, 1, 2, 3. So result plus equals time dot, is it TV NSX? I think it is. Time spec. Oh. Cannot open that. Right. Time spec. It's also a POSIX time spec. Okay, so we don't have to use libc. It's a TV sec and a TV microsec. No, it's time val. I guess it's time.tv sec and then OS frequency times this plus time.tv nanosecs and return. I don't know if this is correct. Let's try to compile this. So Odin build repetition dash file at 28. Now, last start time is OS get time. And tester dot accumulated time. Where's my repetition? Oh, here. Accumulated time is plus equals the OS get time minus the tester dot slash start time. Maybe also using tester. Let's see. Undeclared name libc. Undeclared name time spec POSIX dot time spec. Undefined entry point, yeah, whatever. Just try to do it. Main proc. Invalid type for implicit selector expression. Okay. Undeclared name clock get time. What? I thought you could do this with using POSIX. Okay, apparently you can't, but I don't know why. Is it an I64? No. U64. U64. Has no field unit count, unity count. Okay, this builds. So this probably should have state. Tester state. Tester state enum. Uninitialized. Testing completed. Also try for time U64. And then tester init, tester begin time, tester end time, tester count by units. So procedure takes in a tester, repetition tester, and a try for time U64. Then we say tester.try for time is equal to OS frequency times try for time. So this is 0. The max time, tester.max time, should be equal to U64 -1. I don't know if that works. Maybe there's something like limits, but I don't know. Okay, and then we want something like tester is testing. Tester is testing. And this returns a bool. And last min time. Or time at last min. Okay, so if the tester dot state is equal to tester dot testing, we want to assert that the tester dot let's do using tester state is testing, assert that the opened blocks is equal to the closed blocks. Now this is accumulated time. And then let's say some time, which is kind of blurry. And so accumulate time is this. If the accumulated time is less than the min time, let me say min time is equal to accumulated time. Accumulated time is equal to 0. If the accumulated time is greater than the max time, oh, this is the min time. Max time is equal to accumulated time. Time at last min is equal to os.get time. And then we check if so now current time, os get time. If the current time minus the time at last min is greater than the try for time, we set the tester, the state equal to dot completed, and we set the results equal to state is equal to dot is dot testing, and return. Is that it? And we also want a tester print, but maybe not. So maybe this should also have a name. Wonder if I screwed something up. We'd have to see. So in our hash.odin, we can now test this. So let's say we only have one tester at this time, repetition. So tester, repetition, tester, and tester init. So let's import / repetition tester. Is that right? So this is kind of repetition tester. Tester. So let's let's do something like using repetition tester. Init the tester with, what was it, try for time. Let's try for 5 seconds. And let's give it a name, linked list header map. Okay, we initialize it. Tester. Let's see. And then we do something like a while is testing, right? While, so for tester, for is testing, tester is testing, tester. We do this. Let's build this. -o none. Path doesn't exist. Repetition tester. Repetition tester. Okay, how do you import stuff? Import. I think there was something. How did you do that? I think there was some way you can do that. Uh-oh, file doesn't exist. I thought you could do that. Import file Odin. Import load. I don't like it. Oh, how do you do that again? Path doesn't exist. Maybe pull it into here, move. Yeah, that will work, but I don't want to do that, right? Expected comma got a new line. Repetition tester. Name. Package. Hash. Did you mean tester? Yes. You are right. Tester. Then we want to do a begin time. So begin time tester. We want an end time. And we want the unit tester count units tester. Okay, let's do this. Let's say this returns a U32, U64 field count. That's, I don't know, result. So result is equal to 0 initially, and then we can increment the result based on this here. So result plus equals the length of the common headers and plus the random field count. And then we return. Okay. Tester count units. This is a return value, field count. Field count. Tester field count. Okay. Can assign value of type repetition to invalid type. Tester init. Let's see. Undeclared name repetition. 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 Where is it? In repetition test. Repetition tester. Repetition. Repetition tester. Undeclared name repetition tester. Yeah, that's true. Using. Okay, countercast -1. Are there some limits? Is there something like packages limits like U64 max U64 U64 max UN64 max math bits U64 max one shifted over by 64 minus 1 shouldn't even be possible. So to me -1, is this possible transmute? Can I transmute untyped expression I64 yeah, that works, but I don't know if it really works. Okay, undeclared name current time. So this is in hash. And let's make this a U64. And this also. Hash. So it does not fail, but it also doesn't work. Let's format dot print line the tester. Oh yeah, we absolutely also forgot in the repetition tester to increment the hit count. So let's say hit count plus equals 1. And so else if state, okay, we could do a switch, like switch state case dot testing case dot uninitialized no tester dot state is equal to dot testing. Down, delete to end. Okay, so now it does something. Min times 0. Also, tester.open blocks and sometime plus equals accumulated time. And tester dot closed blocks equals 1. I wonder why min time is 0. Why is min time 0? Oh, because of the first call, right? It's here because of the first call. So probably what we should do is not do it in here, but rather really do the switch here. State case dot testing and case dot uninitialized, or say state is equal to dot testing. Partial switch. So now we have a min time and a max time, and also some time. That's good. Let's try and see what it does with 1 million messages, or 100,000, for example. Min time 7,000. So that's 6 microseconds, right? And it's also only hit, it's been hit. Why did it only hit it twice? Let's wait for that completing. Should we have progress on this? I don't know. So why is open block 2? Okay, I see. So this is probably not what we want, right? We want to begin the time here. And end the time here. Million, probably a little bit too much. Okay, let's make it 100,000. Huh. Okay. Okay, so this is now becoming more reasonable. Let's see. But it also only did it twice, which is... Maybe I should increment this here to 10. Let's see how long it takes for this to complete. Open blocks, only 3. So one iteration through all messages with all headers is 2, 3, 4, 5, 6, 7, 8, 9 is 6 seconds, 6 full seconds. For I also should have had the unit count in here. So unit count, that is 58 million. What if we build it with our aggressive? And no debug. Let's see. We should add a print method to our repetition tester. Like down here, tester print, repetition tester, repetition tester. I don't know, it's like this, right? Proc. Now this is worse, right? 2, 3, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2, 3, 1. Now it's better. Okay. Let's see. So print the tester. Format.print FLN. We probably want the name. Then we want the min time. Percent. I don't know. Is it just the C formatting? Like long digit, long unsigned. Let's see. Tester.using tester. Name at min time. Undeclared. Import core fmt. Print fln. Oh, print fln. Okay, that builds. So the min time. Then we want a new line. Essentially, it is Go but resyntaxed. You mean Odin? Yeah, it's very similar to Go. It has, so the syntax is very, very close to Go. But it also has, I mean, it's a language, systems language with with manual memory management, but with some nice features that make it simpler. And yeah, I think they strive for both low level and being simple, which is so the simple side is inspired by Go. That's right. The max time. We want an average time, which is the tester dot sum time over the tester. Can omit that hit count. And we have to cast this Also, we want to have this in milliseconds. So min so like this, milliseconds, so we have to divide it by 1 million. Divided by 1, 2, 3. Can you do that? Oh yeah, you can do that. That's great. The average time. So this, no, this is a float, right? Or double. So, whoop. Oh, come on. Average time. We also want the throughput, which is throughput in headers per second, or whatever. No. Okay, throughput F64 unit count over F64 sum time. And this should be in seconds, so we have to multiply by the OS frequency. Is that right? So this would be the throughput. Let's make it with O debug and debug. No, O debug. Oh, none. Let's see what happens. Oh no, wrong. Forgot to call the function. In hash.odin, let's tester print tester. Percent? What is this? Und was tun diese? So the HTTP server is basically an example project to see what we can do with the language, like, right? Just to get familiar with the language. I don't know. Why it doesn't format it correctly. Odin format. Odin lang format. So it's extra. What is this? Oh, this is probably because I forgot this, right? I wonder why it builds then. Also, here, forgot the milliseconds and the new line and the tab. So that's the amount of fields per second, but oh, F64, right? Okay, so that formats correctly. If we now introduce a second tester, that okay, let's have a second one, which is tester LL tester. Okay, this will screw everything up. Let's have a second one. So array tester, repetition tester, tester init array tester time to try and array header map. Let's have a time to try. Time to try. 10 seconds. Time to try. Essentially, we also need an arena. We could reuse this one, but yeah, whatever. Mem arena init. We want to say array init. How did I call it? Which hash function I test? At the moment, I wanted to test several things. So at the moment, my HTTP server uses a header map that's basically a linked list, where each entry is just inserted into the list and allocated into the arena, and has a name and a value, and each time we want to get something from the map, we have to iterate through, we have to walk through the list and see whether we can find the entry. Second approach, which is also already implemented, is just have an array with the max HTTP headers limit. And that just inserts into this array, and each time we get, we just iterate through the entire array. And the third approach was, yes, that's a mess, right? But I wanted to make the simplest thing possible first and optimize later. Okay. And the last thing we do is use a hash function to index the backing buffer and implement round robin hashing. Yeah, and we want to profile all of this to compare it. Obviously, probably this thing here will be the fastest one, but I want to know by how much it's faster. Okay. Map arena init, whatever. I mean, I can't really do that, right? Hey. How's it going? Fine. Fine, I guess. I'm currently in the process of testing different header map implementations. Yes. First and foremost, we had the linked list thing. Next up, we try something with an array of max HTTP headers. No, it didn't. I didn't. No, it's just for fun. I want to see how bad it is, and I want to compare it to just an array-based thing, and where we iterate through the entire array. And I also want something where we use a hash function. I also did some research and looked at XX hash. I'm gonna say if you come up with something simpler and faster, by the way. Yes. This looks interesting. It was originally designed for hashing large files and check summing them, but I use a linked list just because it means I can avoid excess copy, but original obviously linear. Yes. We will see. I mean, at the moment, I only implemented. I re-implemented. Yeah, a hashtag would be great, but I didn't find a good way to avoid allocs without limiting the number of header fields I support. Yes, I will limit the number of header fields. I will do that because. Yeah, no, I won't do anything magic with reallocating the hash map if it doesn't fit. I won't do that because at the moment, if we think about it, I have an arena per connection, and if that arena goes out of space, I technically have myself limited as well by the space of the arena. So I don't know if it's that much of a problem to have a limit in there. I don't know. Yeah, I'm gonna grab some water and be right back. A limit is necessary in my opinion, and you always have error to signal the client that they send over too many headers. Yes. This is what I assume. Okay. So we had a test. I had a test harness that tested. Oh. Hash. I implemented a test harness which does this here over and over again. I have initialized some messages with some common headers and some less common headers, and I add them randomly in there, these less common headers, in init messages. And then I just initialize a list, insert all of these entries from the message. Then I don't really know why I do that. Then I go through the fields and get them all. And then I just measure how much time elapsed and do it over and over again until some time has elapsed. And then I print the minimum time that it took, the maximum time, and the average time, and the throughput. That is how many fields we process per second. So that is 1, 2, 3, 1, 2, 3. Yeah. So if we compile this with O-aggressive, is that significantly faster? Also, we would have to look at the assembly output and what it did optimize there. But okay. I also don't know why this time it was so much faster. Okay, so this is the first thing. The second thing I want to test is the array-based, the array-based approach. Yeah, maybe it's just hard to see. Okay, so if I compile it with O-aggressive, takes 337 milliseconds. It's quite something. Yeah. So I need a second tester. Could just have an array of testers, but whatever. And I basically need the same loop. We could abstract this away, but whatever. Just do it for now, like this. I mean, we can reuse the arena. So array init, and this is an how did I call this? Array map, HTTP header map array, array init, array map, and it gets the arena alloc. Also, array init, it gets a size, okay. So the maximum size should be the length of the common headers plus the length oh no. The hashing is just for parsing HTTP messages. In HTTP, okay, where's an example? Curl In HTTP, you get something like this: a get. So this is the method, then the endpoint or the URI, the version, and then you get the headers. And they look like this, like name and value. And for parsing, I need these values. And the thing we do is go through, parse these, and add them to the header map. And then later query the header map to see what the values are. Like something like, yeah, if it has a content length or something, yeah, we'd have to check that. Right, okay. I don't know if that was a good explanation, but whatever. And then times the size of, no. This is the amount of things we need. Arena, alloc. So then the same thing. So we need an array tester, array tester, okay, then array insert, array map, array get, free all. To check the request correctness, yeah, and to also parse it. Because HTTP works like this, that you might have a content length in the headers, and based on the content length, you have to parse the body out of the message. Or if it has transfer encoding or stuff like that. Okay. And obviously, if you have something like cookies or so, then it gets more complex, but you have to parse them and somehow be able to retrieve them later on. Odin built okay, array insert. This doesn't get an arena alloc. Okay, is this correct? Array tester, let's see. Let's build it with aggressive. And let's also decrease the time to try, or no, I don't know. Let's just see what happens. Oh, and we also forgot to tester init. No, it's right, okay. Let's see. Oh no, index 31 is out of range. Yeah, we forgot to reset this. So array map dot length is equal to 0. Array get. Let's look at this again. Okay. I mean, these numbers, I don't know. 1, 2, 3, 1. Okay, so the array-based approach apparently is a bit faster. But this may also be the case because we're doing this in this way here. We're doing the get in this order. I don't know. What if we do it reversed? Reverse. Reverse. No, still faster. Okay, so array-based, still faster. I wonder if it's because the linked list. I mean, the linked list is contiguous. No, we don't have 4 jumps in memory. It's completely contiguous, but we walk it backwards. That might be a problem. I don't know. Yeah, but this seems to be in favor of the array header map, and now we'd have to implement this entire hashing thing. Which I don't want to implement right now because I want to get some food. And oh yeah, thank you for the follow. Okay. If your array map is hash key mod length array, then there's no wonder it's faster than the linked list. Hash key mod length array. No, what we do is in the array map, because the linked list pointer chasing. Yeah, but yeah, sure, you have to do pointer chasing, that's right. But it should be all, I mean, it's all contiguous, right? So it shouldn't be that bad. So in the array, we just walk through the entire array and do a memory compare. There's no hashing here. Yeah, the hashing thing I wanted to implement as well. I don't know why it is. I mean, it's significantly faster, right? Maybe also the measurement is not so accurate because, of course, this is a micro benchmark. I see how it's, yeah, I don't know why it's 50% faster. It's quite a bit. Linked list code, yes. Just the linked list code. Yeah, it's always reversed. If it would be the other way around, probably, maybe it would be. Maybe that would be better. Because, yeah. So, I guess what's happening is that we have the linked list, which is contiguous, that's right. But we always start at the very last element. So this is gonna be this cache line is gonna be loaded, and not this here, I guess. Or in the middle, I don't know. Kinda, I don't know. Yeah, I don't know if it's the memory prefetching that has problems detecting this. This kind of, but I mean, we could add to the tail, right? We could have, we could try it. So tail. So I think on M4 it's even 128 bytes. Likely not that much of an issue. Yeah. I don't. I don't know actually. So what did I want it to do? So if no, we cannot do that, right? We would have to walk the entire list, right, to append to the last element. Or if I just keep track of the tail. No, that wouldn't work. Can we just add it? No. Whatever. Maybe it also has to do something with the input. Maybe it's because it's this order. Maybe if we would reorder this. But I don't think that's actually it. Because it does it multiple times. I don't know. Okay, so this is getting quite messy, this file. But also, this is not really a real-world testing scenario, right? Because we're just, yeah, I don't know. We're just feeding headers. I don't know. Okay, the header hash map. This has some, or backing array. Yeah. Also, I don't know if this is the best thing to do. Like, generate this on the fly and just, I mean, I generate these messages on the fly here in the program. And one pose is markedly and the other is that doesn't stop just because it's no longer in the benchmark. Yeah, that's true. But there are edge cases where you construct your benchmark in such a weird way that it doesn't apply, like that you cannot extrapolate your results. No, the input generation is not included in the timing. Okay, so the array-based hash map. Okay, hash init. And an arena. Header map. Backing array. Make HTTP header entry for the size and the arena. We make a very stupid version of this, but that's okay. Okay, hash insert. I saw that they implemented a hash function, this XX hash, and we just use that. Where are the procedures? If hashing, yeah, I don't know. If the hash is very slow, it can definitely be a problem. Yeah, hashing only becomes an issue when your map fills up. That's right. Then you have a lot of collisions. We want this. Right, but if we have rather small maps, an array might just be fine. But whatever. Okay. So we want to hash. So, no. We want to hash. So let's include import. What was the name? Core hash XX hash. So core hash XX hash. Yeah. If we have a bashed hash function with a lot of collisions, we also have a problem. So header map, I think it's xx hash dot xxh. It was xxh3, right? 32. So digest, or more like index of the key mod the header map dot backing array dot, so the length of this yeah, as your map fills up, you might run into issues trying to linear probe. Yeah. That's right. Yeah, I will separate the files at some point. What if we just do header map? So how do we know whether an entry is empty? Is it just that its key is nil? Maybe. So if backing array at idx dot key is equal to nil, then we say backing array at idx we may have to add a branch here. No, we don't. We can say if to do check the length and return an error if the map is full. Then backing array idx is equal to key value and return. Otherwise, we increment the idx is equal idx plus 1 mod length of the backing array. Iterate for I length map buckets. Yeah, that's right. But I don't have to loop over all of them to know it's full, right? I should have something like a length in here that just tells me whether this thing is full. So do something like here, defer. Otherwise you have insert into the first free space and returned. Length plus equals 1. We could make the size of the backing array the power of 2. And if we are in get, we just, we do the same thing, right? So if this thing is null, we know that we encountered that this thing is not in the array. So we can just say return and set the error to true. Otherwise, we want to if memory compare backing array IEX dot key and the key. Then we set the result to backing, say a field backing array at IDX field.key field.key field.value. Yeah, fair. I tend to not bother, as you need to limit iteration anyway to prevent infinite loops on insert into a full map. I just accept that an insert into full map is guaranteed to be slow. It's an error case. As you don't want to do, yeah, it's true. That's true. So if we go through the entire array and don't find it, we set the error, also return. So we could say something like IDX is equal to 0, IDX is less than, less than the length of, whatever. We'll just do it like this. Error is equal to true. Oh no, this will break. For IDX 0, IDX is less than length of backing array. Maybe we should name this buckets because that's probably better terminology. Buckets field bucket at IDX. field is equal to this. IDX plus equals 1. Let's say digest. Digest plus IDX mod length of buckets. This is the key. Buckets, key. Let's do it like this here as well. So this is the digest. Then we have an IDX 0, IDX less than length of buckets. IDX plus equals 1. The key. Oh, that won't work. Key index. These names are ridiculous. Bucket, that. We don't need that. It's the digest plus the IDX mod the length of the buckets. Key IDX. Oh God, length. Okay, a lot of errors. Let's first build this. Okay, so cannot call a non-procedural length of type 2032. Where's that? Header. Oh, this is 136. This is the buckets and header map length. I think we don't have to do this here. So it's 145, 232. Oh. Count. That's unfortunate. Count. Okay, IDX. And U32. Undeclared name buckets. Are you kidding me? It's 160. Yeah, I don't know why they do that. undeclared name bucket. Yeah, that's true, because it's buckets. Invalid compound literal. Okay, so I think you have to dereference this then, right? Field is this, and how do you do dereference? Like this? Uh-oh. How do you do dereference? Dereference Odin. Why? Ah, no dot. Defer. Okay, this makes no sense. Using header map. Backing array. Buckets. Okay, that compiles. Oh, now we need a yeah, if you're in a very high level language, like, I don't know, Python or so, network programming would be kind of terrible, I guess. But at least if you have a systems programming language, yeah. Okay. Okay, this is the hash tester. Hash. This is an hash init. Hash tester. Hash map. Hash insert. Hash get. Hash map. Hash map dot count. Oh, wait a second. I made a mistake. Array init. Yeah, no. Okay. So hash init this. Now, how big should this be? I don't know. Let's just make it 512. I don't know how good this will perform. No, 512 is probably a bad number. Should make this prime numbers, right? I don't know. Yeah. Yeah, that's true. Memory's not an issue, but I mean, if we make this bigger, the collisions are going to go away. Like, the smaller we make this, the worse it will perform. But whatever. So is not hash map, hash tester. Oh no, that's not the arena. Oh yeah, so the arena, I made a specific size. Let's just make it 4 times megabytes. So I think there was something like megabytes here. Megabyte. Runtime dot megabyte. Hash map. Why is hash map 286 hash get 280? What? You're shattering the name? Oh yeah. Oh my goodness. I wonder if this does anything. There might be a bug. Let's make it a little smaller just to see if it works. It's kind of weird that the... Ooh. Look at how much worse. Huh? So it may be... There might be something wrong here. I mean, we do a lot of integer modulo, which is not good. Maybe something is screwed up. I don't know. I will look at this later. I wonder how many collisions are there. If you force binary and instead the... Yeah. Look at this. This is so much, so much. And also, when we don't do so many messages, for some reason the linked list gets faster again. No, I don't know. Time to try is just how much seconds elapse after the last min was detected until I close the tester. So the hash header map is significantly slower. Might be the hash, it might be whatever. I'd have to look at this. Yeah, we can make it smaller. Time to try, 3 seconds. FNV 1A. Yeah, I mean, maybe FNV 32. FNVA. Yeah, we can take a look at the hash map code. That's the hash map code. I mean, probably we should look at the output assembly. We can make this here a pointer, but I don't know if that changes a lot. I mean, the compiler should hoist that out anyway, so. Do you actually clear the buckets to... Oh no, I don't. That's a good point. Well, well, well. So... And why is the... Wait a second. The free all... This is also wrong. This was for the linked list. We don't have to free it, right? Free all here. And free all here. Okay, so in here, now we have to do that for each message, right? And then it's in the timing, the reset. So setting them all to nil will be inside the timing. Yeah, guess what? I have to change this. I have to change this a little bit. I have to do that, and then in the repetition tester, do accumulated time plus equals this. And accumulated time and in here we set accumulated time equal to 0. Okay, and the next thing is clear, hash clear. Hash clear. For bucket in buckets. Bucket dot key, no, bucket dot value. Yeah, I just have to reset the key, right? And in here we can do this as well. We can put it in here, but it wouldn't really make a difference. But up here, let's read this. No, we were, oh God. Reverse. Here we can also do that. So we only track that time. That should be similar now, but I'm not sure. Yeah. So okay, so the array header map seems to be, yeah, now the hash header map is a little bit faster than before, just a little bit faster than before, but still slower than both the linked list and the array header map. So let's try another hash function, fnv32a. Get a larger sample size. Probably a good idea. Yeah. What? Yeah. This is headers per second. This is a bad number. I don't even know if it's correct. Yeah, it is headers per second. So core hash. Let's just try the other one. Core hash, and what was it? FNV. Core hash dot fnv1a 32a. Yeah. Hash fnv32a. for hash. Now we already get collisions of the namespace. That's great. Oh man. Package must be unique. Okay, whatever. I will eat something. We leave it at that. We would have to look at, we could also look at power of two sizes and see whether using an AND instead of a modulo would help. I don't know. We would have to look at it. So thank you for joining in. Yeah, you can do that. That's nice. Yeah, see you maybe later. Bye.